Hi, welcome. This is Additional Mathematics from 5 textbook, Chapter 3, Integration, Formative Exercise 3.3. Okay, so let's get started. So the first question, you're supposed to find the definite integral for this. So now remember, for composite function, when you integrate part A, you have to copy the bracket, increase the power by 1/6, divide by the increased power, differentiate inside. So there's a -1 here. In the bracket there's a -x, differentiate -x is -1. So lower limit is -1, upper limit is 3. So we're going to start inside. For me, I like to take out -1/6, just leave it outside. When I put 3 inside, 2 minus 3, I'll just write -1 power 6. When I put -1 inside, 2 minus -1 is 2 plus 1, which is 3 power 6. So you can use your calculator directly. So here I got 1 minus 3 power 6 is 729. So we can leave it as 728 divided by 6, which is 364/3, or 121 1/3. Either way is fine. So for part B, you can't integrate first. You have to simplify this. I think maybe I can take out negative. So because I see the -6, there's an 8 and 2, all these are divisible by 2, so I'm taking out -2. So this is -3 to 2. So I like to take out negative because it's easier for me to factorize. But if I take out negative from the top, I think it's better to take out the negative from the bottom of the denominator. So now we can cancel negative, left with +2. And when you factorize this, this is 3x x 2 minus plus or minus 6 plus 2 is -4. So now I can cancel this. So basically you just integrate 3x plus 2. So this part here, for me, I like to use composite function. I think it's easier to use composite function rather than integrate one by one. So we can treat like a bracket power 1. When you integrate, you increase the power by 1 to 2, divide by the increased power, differentiate inside the bracket, differentiate 3x, I get 3, lower limit is -3, upper limit is 2. So we can cancel them, left with 1/3. If you put 2 inside, 2 times 3 is 6, 6 plus 2 is 8. So you have an 8 square. And if you put -3 inside, you get -9 plus 2, which is -7, sorry. And -7, you can square it. Okay, actually you can just write this as 64 minus 49. 15 divided by 3, just 5. Okay. Alright, C, you can't integrate unless you expand. First I'm going to expand this. I'll get -2 to 3, 2x power 4 minus 2x power 3 dx. So when I integrate this, I copy x, increase the power by 1, 5 divided by 5. Now this is 2x power 4/4. So I just want to cancel 4 and 2, left with 2. Lower limit -2, upper limit 3. So let's put 3 inside, 2/5. 3 power 5. I'm going to write straight away. 3 power 5 is 243. 3 power 4 is 81. Minus, put -2 inside. -2 power 5 is -32. -2 power 4 is just 16/2. Okay. Now you can just use a calculator. Just type in one shot. You should get 155/2, or 77.5. Okay, so that is question number 1. Let's move on to question number 2. Okay, question number 2. We have to use the laws of definite integral. Now we know this is 0 to 3, fx dx is 2, 2 to 5, gx dx is 7. So to find this value, right, for part A, I'm going to take out half. And at the same time, you notice that lower limit is 3, upper limit is 0. Whereas this is 0 to 3. Now, I hope you know this. One of the laws of definite integral is that if you have a to b, you take out negative, this becomes b to a fx dx. And if you have a constant here, half, you can just take it out. So I'm going to change the limit and put a negative outside. This is going to be 0 to 3 fx dx. As for gx, I think I'll just take out 3. This is 2 to 3. 2 to 3 gx, sorry, it's 2 to 5 gx dx. Okay, wait, let me just rub this off. It's 2 to 5 gx dx. Okay, so, and we can substitute fx with 2, gx with 7, so it's -1 plus 21. Answer is just 20. Alright, for part B, you're supposed to find the value of these two. So this is 1 to 3 kx dx. I'll break it up. 1 to 3 dx, then 3 to 7 kx dx. Now 1 to 3, 3 to 7, you can combine it to 1 to 7. Yeah. Okay. Let me just recap. A to B fx dx plus B to C fx dx. You can just combine these to A to C fx dx, provided number one, they must have the same function. Number two, the upper limit of the subsequent integral is the same as, sorry, the lower limit of the next one is the same as the upper limit of the one before. So we combine this to 1 to 7, and when you integrate 3, you get 3x. This is from 1 to 3. Now you don't have to integrate anything, you just have to use this information here. This is 10. Yeah, integration 1 to 7 kx dx is just 10. Now for me, the 3, I can take it out. I put 3 inside, so it's inside x, so it's 3 minus 1. 3 minus 1 is 2. 2 times 3 is 6. The result is just 4. Okay, that is question number 2. Okay, let's move on to question number 3. Now, the area under the graph for this curve, yeah, bounded by x equals 1, x equals 4 is 28, 1 and 2. Now, it doesn't matter how the curve looks like. So, we'll just do a sketch. This is 1 to 4. Yeah, it looks something like this. Okay, so we are finding this area. So we integrate 1 to 4. The function is x squared plus hx minus 5 dx. Result 28, 1 over 2. So when you integrate x power 2, you increase the power by 1, 3 over 3. This is hx squared over 2. This is 5x, lower limit 1, upper limit 4. Maybe I write this as 57 over 2. Let's put 4 inside. 4 power 3 is 64. 4 power 2 is 16. 16 divided 2, I'm just going to write 8 straight away, 8h. I'll put 4 inside 5 here, so it's 5 times 4, which is 20. When I put 1 inside x, we get 1 over 3. This is 1 over 2 and 1 over 2h, and this will be just 5. Okay, now maybe I minus this out. See, 64 over 3 minus 1 over 3 is 63 over 3. 63 over 3 is 21. And maybe this is a bit ugly. Let me just make it a little bit better. This is 1 over 2h. Okay, 8 minus half h is 7.5. Minus 20 minus 5. So minus 20 plus 5 minus 15. This is 57 over 2. Okay, now 27 minus half, minus 5 is 6. 6 plus, maybe I write 15 over 2h. 57 over 2. If you don't like fraction, right, maybe I just times everybody by 2. I get 12 plus 15h equals 57. 15h is 57 minus 12, which is 45. 45 divided 15, h is just 3. Okay, so move on to number 4. Alright, so this question is rather interesting. So diagram shows a curve y equals x squared drawn and with a straight line y equals 4. Right? Line the gradient x equals with the gradient -1 is drawn. It passes through point h02. So, and it intersects the curve at k. Now, to find the coordinate of point k, you need to find equation of this line. Okay, to find equation of this line, we know the gradient. You know the y-intercept, right? My gradient is -1. My y-intercept is 2. Just use y equals to mx plus c. So, can I not write -1x? Just write -x plus 2. So this is your first equation. Your second equation is y equals x squared. We just have to solve them simultaneously. 2 in 1, 1 in 2 doesn't matter. Okay, so minus x plus 2. So you want to bring it over, double bracket, factorize it. 2, 1 plus and minus. So x is either 1 or minus 2. But we can see k is on the right hand side. The curve and this straight line, they intersect on the right hand side. That means your x is more than 0, so your x has to be 1. So when you sub inside any equation, equation 1 or equation 2 also can, minus 1 plus 2, your y is 1. So your point k is just 1, 1. Okay, next you're finding the ratio of area to P to area of Q. I think it's easier to find area of Q first, then we can find area of P. Now you can see Q is basically this trapezium minus this integration. Alright, so K itself is 1, 1. So that means this is 0, this height is 1, and this height is 2. Can you see? The y-intercept is 2, this is 2. K, since K is 1, so the length here is also 1. Maybe I just erase the 0. This is just to show the length of your trapezium. And the second one, I will have to integrate. So area of Q, I'll use area of trapezium, half sum of parallel side times height, minus integration 0 to 1. My function is x squared dx. So this is 3 over 2 minus x cubed over 3, 0 to 1. So when I substitute 1 inside, I'll get 1 over 3 minus 0. So this is 9 minus 2, 7 over 6. Yeah. So area of Q is just 7 over 6 square unit. Now let's find area of P. Now P is a bit more complicated because if we are only interested in finding the shaded region, right? Let's say I'm just finding this whole part here, then I will take a rectangle minus area underneath. Yeah, so basically I'm taking a rectangle minus area integration, but you still need to minus area of Q to get the area of P. That's why I would prefer to find area of Q first. Yeah, I can subtract later. Now area of P consists of a rectangle. Now by the way, when your y is 4, this height is 4, this will be 2. In case you do not know, y is 4, x squared is 4, x is just 2. Don't have to put plus minus, so we know this length is 2. So this will be integration 0 to 2, right? So, and then you can find Q. I mean, you already know Q is 7 over 6. So this is 4 times 2 minus integration 0 to, your function is x squared dx. Area of Q is just 7 over 6. So let's count. This will be 8 minus x cubed over 3, 0 to 2, 7 over 6. So when I put 2 inside, 2 power 3 is 8, minus 0, I think I don't have to write. So for me, I can times top and bottom. Maybe you can use a calculator. So I take 8 times 6 is 48. This is 16. This is 7 over 6. I'll get 25 over 6. Okay, so the ratio of area to P to area of Q, it's a bit ugly, let me make it better. Area of P to area of Q will be 25 over 6 is to 7 over 6, just times everybody by 6. So the ratio is 25 is to 7. Okay, all right, number 5. So for this question, the first part, they ask you to sketch the curve of y equals to 6x plus x squared. So now 6x plus x squared, you already know how to sketch this, right? We first let at x-axis y is 0, okay? Let y be 0. So we take out x, 6 plus x equals 0. X is either 0 or negative 6. Now I know my coefficient of x squared a is more than 0. I know it's a minimum, right? So I know the graph should look like this. I try to draw as big as I can. Alright, so this will be negative 6. This is positive 0, x and y. Okay? Now, then they say find equation of tangent at the origin at the point x equals to 2. Okay? At origin x equals 0. Equation of tangent means you have to differentiate. So let's differentiate first. dy dx. I will get 6 plus 2x. When x equals to 0, my dy dx is 6. Alright, so equation tangent, since it passes through 0, 0, that means my y-intercept is still 0. My gradient of tangent is 6, so y equals to 6x. That is your equation tangent at the origin. Now at point x equals to 2, my dy dx will be 6 plus 2 times 2, which is 10. So I need to find what is my y value. I need a coordinate y. So we take 2, put inside your y. So 6 times 2 is 12. 12 plus 4, 16. So I use y minus y1. My y1 is 16. Gradient is 10. X minus x1, which is 2. Y is 10x minus 20 plus 16. Y is 10x minus 4. So I've got equation of 2 tangent at this point. Okay, now the next part is a bit harder. The 2 tangent intersect at point A. So we call this equation 1, call this equation 2. I can sub 1 in 2. Okay, I think I'll do it here, 1 in 2. So 6x equals to 10x minus 4. 4x is 4x. Yeah, x is just 1, right? So then you sub in equation 1, your y is 6 times 1, your y is 6. So your coordinate point A is just 1, 6. Okay, now let me illustrate from this curve here. Okay, maybe I can draw the curve better. This curve looks a little bit ugly. I need a nicer looking curve. So you go like that, down like this. Okay. Okay, maybe a little bit better. Let me undo this. Okay, one more time. Okay, nah, not any better. Anyway, it's okay. So let's say the first tangent, when x equals to 0, this line is a tangent, right? This line is y equals 6x. There is a second tangent. Let me use the blue line at x equals to 2. So the graph probably like this, right? This line is y equals to 10x minus 4. Alright, and the tangent is this point at x equals to 2, right? So what we need to do is to find the area bounded. So let me move this up a little bit. This one will be higher. Alright, so you can see that, yeah, this, as we got earlier, this 2, well, this point is 10, this is 16, sorry, this is 16, this is now, okay, let me make it better, this is 16, this coordinate point A is 1, 6, this is your x-intercept. You can find the x-intercept. We know for y equals to 10x minus 4, when your y equals to 0, your 10x minus 4 equals to 0, x is 4 divided by 10 is 205. Now why is it important that I find this? Because I want to find area of these two triangles, because you're finding area bounded by these two. Sorry, it's very hard to see. Maybe I highlight using this. I'm finding this area, very small area here, bounded by these two tangents. Yeah, the two tangents intersect A, find coordinate point A, then find area enclosed. Yeah, find the enclosed area by the tangent and the curve. Now a bit hard for you to imagine, but I want you to think this is the curve. You first minus this triangle. Now this triangle is an obtuse angle triangle where your base is 2/5. Your height is 6. Your height is the coordinate here, 6. Now the second triangle, okay, let me rub this off. I'm afraid I don't have enough space. I need to minus a big triangle here. This triangle is bigger. The tall triangle here, right? I'm referring to this triangle. Let me just highlight. I'm referring to this triangle here. This triangle here. Okay, the blue triangle. The first triangle is the red triangle. The red triangle is over here. Okay, small one. The second one is a blue triangle. So I need to find the length from here to here. Now, if you take 2 minus 5 or minus 2 over 5, what is 2 minus 2 over 5? Is 1 3 over 5, right? 1 3 over 5 you can say is 8 over 5, right? And this height is just 16, right? So this one you have to use integration 0 to 2, right? So I'm going to find the area by integrating 0 to 2. The function is 6x plus x squared dx. I minus the area of first triangle, half times base times height. I minus area of second triangle, half times base 8 over 5, height 16. Sorry, no space. So this will be, when you integrate, this will give us 3x squared plus x cubed over 3 from 0 to 2. Now, area of first triangle, if you simplify, it's just 6 over 5. Area of second triangle, you can cancel, is 64 over 5. Now, this area shaded region, this area integration here, we sub 2 inside. 3 times 2 squared, 4 is 12. 2 cubed is 8, 8 over 3. Now, you can put this together. This is going to be 70 over 5, which is 14. So 12 minus 14 is negative 2. 8 over 3 minus 2 is going to be 2 over 3. So your area is very small. 2 over 3 square unit. Yeah, I would say this question is a bit challenging. You need to draw the diagram bigger so that you're able to see. Yeah, too small, you can't really see it. Okay. All right, question number 6. Okay, now this question personally, I think they have to rephrase this because you see, you read the question. Find a volume generated in terms of pi for the region bounded by the curve. So let's sketch the curve. Y equals to x squared plus 2. Now x squared plus 2 means your y-intercept is 2. We know the graph looks like this. Okay, bounded by the curve, the line x equals to 1. X equals to 1 is here. X equals to 2 is over here. You see, when they say area where the region bounded by this curve, this line and this line is actually incomplete because you only have this curve, this line, this line. You don't have the fourth boundary. Now, either the question should say x-axis, right? Then if this x-axis, we are talking about this region here. Or the question should say, let's say, line y equals to, let's say, 8. So then we know this is the region. So question never mentioned that, you see. So now what I've done is I work it out, and in order to match the answer, I realized that the question, the intent, the purpose of the question is that they want you to find your y. So I think they should change the question. Your x equals to 1, your y is 1 squared plus 2, which is 3. So they should say this is y equals to 3. Yeah? So this is y equals to 3 here, correct? Now, then when x equals to 2, your y is 2 squared plus 2, which is just 6, right? Because when they say the curve x equals to 3, y equals 6, okay, this one makes sense because this is this region, right? So now it doesn't matter whether you rotate 360 or 180, you will get a full solid. So guys, I think the question should be y equals to 3, y equals to 6. Then you will be able to get the answer at the back. Otherwise it's not. Otherwise it's not, because you are short of one boundary. Like I said earlier, the curve x-axis, x equals to 1. It is open. I'm not sure whether this is the upper region and there's no limit to the upper region. I'm not sure whether it's the lower region and there's no limit to the lower region. So in a way, it's incomplete. But when they say it's bounded, the curve goes like this, right? So yes, there's another boundary over here. When you rotate it, yeah, this is what you're getting, right? Okay, so we'll just take make the assumption y equals to 3 and y equals to 6. So to find the volume, remember when you rotate about the y-axis, the formula is pi x squared dy. My lower limit should be 3, upper limit should be 6. Okay, and we need to make x squared as a subject. X squared is now y minus 2. So I'm going to put the pi outside. I'm going to put y minus 2 here, dy Let's integrate. I'm going to use composite function, increase the power by 1, divide by the increased power, differentiate inside the bracket. So this is pi over 2, put 6 inside, 6 minus 2 is 4, 4 power 3, 8. This is power 2, sorry, 6 minus 2 is 4, 4 power 2 is 16, 3 minus 2 is 1, 1 power 2 is just 1, so this is going to give us 15 over 2 pi, yeah, which is the same as the answer given in the textbook. Alright, let's look at question number 7. Alright, so the first thing I need to do is to find the coordinate of point P. So, sorry, coordinate point Q. Q is your x-intercept of your tangent. So this one related to differentiation. Step 1, we differentiate dy dx. This will be 2x. Then we sub x with 1. So you will get 2 times 1, which is just 2. So this is your gradient tangent. So to form equation of tangent, I use y minus y1. My y1 is just 5. Gradient tangent is 2, x minus x1. Y is 2x minus 2 plus 5. Y is 2x plus 3. So this is your equation of tangent, but sorry, I don't need this. I need to find a y-intercept. My y-intercept is 3, so Q is 0, 3. Next, find area of shaded region. Notice your shaded region is bounded by this integral minus this area trapezium. Now we already know this is 3. The height, this line is be 3 because your Q is 3. This is 5. You can see this is 5, and the length from here to here is 1. The first area we have to use integration 0 to 1 of x squared plus 4 dx. Second one, I'm going to use area of trapezium, half sum of parallel side times height. So when you integrate, you get x power 3 over 3. This will be 4x, 0 to 1. This will be 8 over 2, which is 4. When you substitute 1 inside, okay, you should get 1 over 3. Okay, part C. Calculate the generated volume in terms of pi when the region bounded by the curve y-axis y equals 8. Now y-axis, the curve y-axis y equals 8. Now y equals 8 should be somewhere here, y equals 8. For this curve y equals x squared plus 4, your y-intercept is 4, so your region should be here, right? Revolve fully about the y-axis. So we know the lower limit should be 4, upper limit should be 8. So if you want to find volume rotated about y-axis, remember you need to use x squared dy, lower limit 4, upper limit 8. So make x squared as a subject. So x squared will be y minus 4. Let us take out the pi. This is y minus 4. Again, I'm just going to use composite function. I find composite function is easier. Square to differentiate is 1. 4 to 8, take out pi over 2. When you sub 8 inside, 8 minus 4 is just 4. 4 squared is 16. When you put 4 inside, 4 minus 4 is 0. 16 divided by 2 is 8 pi. So there you go, 8 pi cubed. Yeah, because it's volume. Alright. Last one, question number 8. Alright. The first part is you're supposed to find the coordinate point A. So, okay. Point A will be the x, the intersection between these two equations. So maybe I let 3y equals 8 plus 2x as equation 1. Now the second equation, y squared is 6 minus x. So maybe I make x as a subject, 6 minus y squared. Equation 2. So when I sub 2 in 1, 3y is 8 plus 2, 6 minus y squared. So it's 8 plus 12 minus 2y squared. Bring over 2y squared plus 3y minus 20 equals 0. We can double bracket factorize it. Suppose you get 2 times 20 is 40. Factor 40 is 8 and 5. So to get 8, I put 4. To get 5, I put 5 here. So this should be a plus and a minus. Now you can see that your y is supposed to be positive because your y is above, the y coordinate is above the x-axis. So we take y equals to 5 over 2. So your x, I'll just sub inside any equation below. I think I'll sub inside equation number 2. Your x is 6 minus 5 over 2 squared. So this is 25 over 4. So it's negative 1 over 4. So your coordinate point A, negative 1 over 4, 5 over 2. Okay, so I'll write over here. Next one, calculate area of shaded region Q. Now, shaded region Q is above, it's bounded by this straight line. So this straight line, if you move it down, you're actually getting a trapezium. You minus this integration. This integration is your shaded region P. So now for this trapezium, we know the length from here to here, this is negative 1 over 4. It's quite an ugly number, right? And the height is actually 5 over 2. Yeah, this is 5 over 2. This is 1 over 4. Ignore the negative because we are finding the length. The length is positive 4. Now I need to find the x-intercept, the y-intercept. So we know y-axis, x is 0. 3y is now 8. Y is 8 over 3. So this height is 8 over 3 here. So I can use area trapezium. As for this, I need to use integration, but the limit is negative 1 over 4 to 0. So my area will be, let me take half sum of parallel sides times height minus integrate negative 1 over 4 to 0. Your function is 6, is a curve, 6 minus x. Here you notice that is the positive side. I hope you know when you square it, there's a plus minus. The plus is the one on top, the bottom is minus. So I'm only interested in the positive square root, so the one above. So we just take power half dx. So now this number is a bit ugly. So if you take 5 over 2 plus 8 over 3, you should get 16 plus 16 plus 15, 31 over 15. So the 15 you have to times 2, 31 over 6, sorry, 31 over 6, 6 you have to times 2 times 4, so it's 48, right? Now, then you minus, when you integrate this, is 6 minus x, increase the power by 1, 3 over 2, divide by 3 over 2, differentiate inside the bracket, there's a negative 1 here, lower limit negative 1 over 4, upper limit is 0. So let us substitute. Now, there's a negative here. When I flip it up, it's a positive, positive 2 over 3. Let's put 0 inside. You get 6 power 3 over 2. You put negative 1 over 4. So this is 6 1 over 4. Now 6 plus 1 over 4 is actually 25 over 4. A bit ugly. Yeah. So this is 31 over 48. Now maybe 3 over 2, you need to think 6 power 1 times 6 power half, which is 6 root 6, right? So I'm going to write 6 root 6 here. Then you minus 2 over 3. Now, when you square root 25, you get 5. 5 power 3 is 125. Square root 4 is 2. 2 power 3 is just 8. So you just have to add this up. Now, number a bit ugly. So I got 12. The 6 can cancel with 3, left with 4. So it's 4 root 6 minus 469 over 48. Yeah. So if you leave it in exact value, this is the answer. But I think textbook final answer they gave us in decimal. So if you use a calculator type in, you should get 0.027. And this is the answer given in your textbook. I don't know why they choose such a ugly number. Should use a I wouldn't use this equation, right? And this equation, so you get very ugly number. Anyway, ugliness is not a crime. Now, how do you calculate volume generated when the region P is rotated 360 by x-axis? Okay, this one is much easier. When you rotate 360 by x-axis, you need to make y squared as a subject. So I already have a y squared 6 minus x. So my volume will be integration. Lower limit is negative 1 over 4, 0, pi y squared. My y squared is already 6 minus x dx. So I'll take out my pi. When I integrate, I use composite function, increase the power by 1, divide by the increased power, differentiate inside the bracket. This negative 1 over 4 to 0. Let's take out negative 2. So let's put 0 inside. I'll get 6 squared, which is 36. If you put 104 inside, 6 plus 104 again, 25 over 4, then you square it. Now you can use a calculator. This is 36, 125 over 8. You minus, I think you just count one shot, you should get 49 over 32 pi or 117 over 32 pi unit cube. Alright, I think that's all for this formative practice. Thank you for watching.